All right, hey Buffaloes, we're going to do some stoichiometry at home today. We're going to use some baking soda and only baking soda and a propane torch, so it should be kind of fun. We're going to see what happens here. I've got my notepad. We're going to be writing some stuff down. So this is going to be a reaction where we take baking soda, and baking soda is NaHCO3. And when you apply heat to it, it decomposes. It decomposes into sodium carbonate, which is Na2CO3, because carbonate is a polyatomic ion with a -2 charge. We get some water out of it. Hopefully we'll see some water today. And it releases carbon dioxide gas. Okay? Now if you look at this, you might notice that it's not balanced. So we have to put a 2 here in order to balance it and make everything fixed. Okay? So what I'm going to do is I'm going to weigh a test tube first. So we're going to turn on our scale. Grab our test tube, place it in here, and looks like we get a mass of 19.01. Yep. So we're going to say that the test tube is 19.01. Okay. Then what we're going to do is we're going to add in some baking soda and see what the measurement is. So give me a second here. Let me set you guys down. Whoop. Okay. Grab my baking soda. Place some in the test tube. Doesn't particularly matter how much. Okay. And we'll set it back into the scale. And we'll see that it is 20.49. So we'll go back to our notebook and say with baking soda, it is 20.49. That means that our grams of NaHCO3 is 1.48 grams. Now, the question in your homework this week should be something like if 1.48 grams of baking soda, NaHCO3, is decomposed, how many grams of sodium carbonate will be left. So what we're going to do is we're going to do some stoichiometry here. We're going to take our 1.48 grams of our sodium carbonate, which is NaHCO3. All right, and we're going to set up a little fence post. Now, the first step in these triple fence posts is always using the molar mass of the known. Okay, since there's grams of sodium carbonate down here, we're going to put grams of sodium bicarbonate down here, or hydrogen carbonate, whatever it is. Okay, and then we'll have 1 mole of NaHCO3 on the top there. Now when we add that up, we'll take the 23 from sodium, add 1, add 12, and add 48. So we should get 84 grams out of that, like we did with our last example. But the next step's a little bit different. You see, I'm going to go from this formula right here to this formula right here, which is different. These are two different compounds. So we have to use what's called the mole ratio in the middle here. And the mole ratio, we're going to put moles of sodium bicarbonate on the bottom. That's the stuff that I know. The stuff that I don't know is moles of the Na2CO3. So those are very close together, but there are different compounds. Now, these numbers here for a mole ratio we get from this equation. Notice how there's a 2 in front of baking soda, and there's nothing in front of the Na2CO3. So we put a 1 there and a 2 here. Then the last step is the molar mass of the unknown. So that'll be a third fence post. We'll have moles of Na2CO3 on the bottom. I know it's that because I'm always setting this up. Look, grams cancels out. Moles cancels out. That's the same thing, right? Same thing. Here, same thing. So this is the last one that's going to cancel out. And on the top, we're going to put grams of Na2CO3. Now this will be 1 mole because whenever we're comparing it with grams, it's 1 mole. Look here. Even when I used a 2 here in front of mole, it's a 1 here because I'm comparing it with grams. All right. So if we add that up, I think that's 23 times 2, it's 46, plus 12, 58, plus 48. Yeah, it's going to be 106. 106 grams. So we're just adding that up from the periodic table. Okay? So we get this big long list, but it's just 3 things, right? The molar mass of the known, the mole ratio, and the molar mass of the unknown. So keep that straight as you're going through. Okay? And it's like that for every single problem. So we're going to take 1.48, divide it by 84, divide it by 2, and then times it by 106. And I happen to have a handy dandy calculator right here. Okay, if it works. Go in. There we go. All right. 1.48 divide 84 divide 2 times 106. I get 0.933. We'll say 0.934 to round it with sig figs. So we should get 0.934 grams of Na2CO3. Now, if this works, then if I add the 0.93 to the test tube, 19.94, is as low as this thing should go. It's 20.49 right now, but it should go down to 19.94. So let's find out what happens here, okay? All right, so I got my baking soda. It's in the test tube. I got my heating source here. Remember, we already did the stoichiometry, right? So we're just gonna heat it up, trying not to, heat the glass too much. Stir it around. Just get it hot enough. We can actually tell if it's working by holding it on the side here. Oh, yeah, it's working. Woo, that's warm. Look at that. Baking soda is boiling. What's up with that? Oh, hey. Remember what one of our products was? One of our products was H2O. And if I look here, you should see a bunch of condensation on the side from the water that's being created. So I'm literally boiling the baking soda, but not boiling the baking soda, just boiling the water that's being given off and it breaks down. Okay, now I know I'm not quite there yet, but let's put it in there anyway. Let's see what the scale says. Okay, go in here, press on. It's at 0. We shouldn't go lower than 19.94. We're down to 20.33. So we're lower than the 20.49 that it was, because remember, it's losing carbon dioxide and it's losing water. But we're going to keep going until we get all of it. Right? Okay, so let's see if we can get this again. Maybe you didn't see it the last time. So we're heating the baking soda. You can kind of see it moving. You see that? Oh, no, let's try it again. I'm going to get this on camera. Oh, okay. Hopefully you can see it. Oh, I missed it again. Seems that every time I try to bring it to the camera, it stops moving. We might actually be done with it all. Oh, we got a clump. That's what's going on. Sometimes the water clumps to the baking soda. Okay. Alright. So let's see if it went down again. Turn it on. Place it here. We're down to 20.16. So there's probably a little bit more that it can go down, because remember, we should end up with about only 0.94 if we get all of it. We started with 1.48 grams. At 20.16, we're down to what, 1.15 grams, right? Down to 1.15, but we're headed toward that 0.93. And if I kept going, this would keep working, but I don't want to be longer than 10 minutes here. So take a look at this. Like, it's always the same step. You're always going molar mass unknown. You're always using mole ratio, and you're always using molar mass of unknown. There's always two substances you're dealing with, and you have to use that mole ratio in the middle. So please, by all means, try to get a hold of me and ask questions when you need it. Those two assignments from this week, that's all I have for you guys, okay? We'll catch you next week after Monday, because there's a snow day on Monday, technically, even though there's not going to be any snow. So, yeah, that's a thing.